So now we are talking about the basic law on which we build our energy balance calculations or our energy balance equations, which is very similar to what we do in mass balance. So in mass balance, the basic principle is the principle of the conservation of mass. So we said that mass can neither be created nor destroyed. The same here. So in the energy balance calculations, we build our equations and our calculations on the principle of the conservation of energy. So energy can neither be created nor destroyed. It can be transformed from one form to the other. So this is the basic concept or the basic principle of energy balance. So according to this principle, we call this again the conservation of energy. We can talk about the different forms of energy. So we can now understand that we have different forms of energy, and energy can be transformed from the internal energy to potential to kinetic. We're going to talk about these forms of energy in details. But for now, this is the main concept that we want to discuss. There are some basic ideas that we need to understand because these are very important, and we need to understand them well because this is what we are going to be building our equations and the rest of the derivations on. So we have two types of systems. One of them is called the open system, and the other is called closed system. A system is open or closed according to whether or not mass crosses the boundary, and this is very important that we define the type of system as open or closed based on the mass flow. Is there a mass that crosses the system or not, or the system boundaries or not? It's mass, not energy. So you can still have a closed system, but um, there is energy going in and out. So the open system is the system where mass crosses the boundary. It's like the continuous processes, the semi-batch processes. Something is going in and something going out of the system. So this is the mass. It's not the energy. The mass is going in or out of the system. The closed system is the system where there is no mass that crosses the boundary, like the batch system. Any system that is sealed, it's isolated. There is no flow of energy, flow of mass. I'm sorry, in or out of the system. This is called a closed system. Still, a closed system can have energy flow in and out of it. It's not mass, it is energy. But so the energy, it's important to quickly review the units of energy. So energy is has the units of force multiplied by distance. The most famous unit of energy is called the joule, which is Newton multiplied by meter. Joule is the SI unit energy, the energy unit in SI unit system. And it's called, as we said, joule. It's Newton multiplied by meter. Newton is kilogram meter per second square, so it's going to be kilogram meter square per second square. So it has the dimensions of ml power 2 t power minus 1. It can be also written in another way, that it's Newton multiplied by meter. So if we divide by meter square multiplied by meter square, it's going to be Newton per meter square multiplied by meter cube. So it's going to be Pascal, which is this, Pascal multiplied by meter cube. So it's the joule is force multiplied by distance or pressure multiplied by volume. Both are definitions of energy, or the units of energy. It can be expressed in calories, which is 4.18 joule. This is 1 calorie equal 4.18 joule, or the British thermal unit, which is the unit used in the British system, or what's called the US systems in some cases. So it's called the British thermal unit, and it's equal to 252 calories. British thermal unit is a very, very famous unit of energy, and it's used in many industrial applications, especially for the pricing of natural gas. The natural gas might have different compositions depending on its source, where it's coming from. So the prices vary according to the quality of the natural gas, the composition of this natural gas, how much energy you can get out of it. So since the natural gas is primarily used to produce energy, so we use it as a fuel that we burn in order to produce energy. So we price the natural gas based on the amount of energy we can get out of it. So it's not priced based on in many cases the price is not per kilogram, it's not per meter cube, it is per thermal unit or per million thermal unit. So this is the thermal unit, which is BTU. So we see how much energy we can get, how much amount that we use to produce million British thermal unit, and this amount is what we set the price for. So this might be smaller in some cases, it might be a larger amount in some cases, depending on the heating value of the natural gas. But this is what we use. So that's why it's an important unit. The British thermal unit is an important unit, and it's equal to 152 calories. And we know the calorie 4.18 joules, so you can calculate how much energy in joules per BTU. So this is the British thermal unit. So now yeah, this is kind of quick introduction on the principle of energy balance, which is the conservation of energy, the different systems, the open and closed systems, and the units. And starting next video, we will be talking about the forms of energy, and then we will go from there to the energy equation or the conservation of energy for open systems and closed systems. So I'll see you then, inshallah. Goodbye.